solar energy reactions. And I'm not sure that our own scientists know about the carbon effect in converting hydrogen to helium. So this may be interesting to some people. In those suns which are encirculated in the space energy channels, solar energy is liberated by various complex nuclear reaction chains, the most common of which is the hydrogen-carbon-helium reaction. In this metamorphosis, carbon acts as an energy catalyst since it is no way actually changed by this process of converting hydrogen into helium. Under certain conditions of high temperature, the hydrogen penetrates the carbon nuclei. Since the carbon cannot hold more than 4 such protons, when this saturation state is attained, it begins to emit protons as fast as new ones arrive. In this reaction, the ingoing hydrogen particles come forth as a helium atom. Reduction of hydrogen content increases the luminosity of the sun, and the sun is destined to burn out. The height of luminosity is attained at the point of hydrogen exhaustion. Subsequent to this point, brilliance is maintained by the resultant process of gravity contraction. Eventually, such a star will become a so-called white dwarf, a highly condensed sphere. In large suns, small circular nebula, when hydrogen is exhausted and gravity contraction ensues, if such a body is not sufficiently opaque to retain the internal pressure of support for the outer gas regions, then a sudden collapse occurs. The gravity-electric charge give origin to vast quantities of tiny particles devoid of electrical potential, and such particles readily escape from the solar interior, thus bringing about the collapse of a gigantic sun within a few days. It was just such an immigration of these runaway particles that occasioned the collapse of the giant nova of the Andromeda Nebula about 50 years ago. This vast stellar body collapsed in 40 minutes of Urantia time. As a rule, the vast extrusion of matter continues to exist about the residential cooling sun as extensive clouds of nebular gases, and all this explains the origin of many types of irregular nebula, such as the Crab Nebula, which had its origin about 900 years ago, and which still exhibits the mother sphere as a lone star near the center of this irregular nebular mass.